Good morning to all. If you are able to hear my voice, mention in the chat box. Just type good morning so that I will come to know that you are able to hear my voice. Are you able to hear me? Okay, then I will start the class. So this root locus problem, partial half of the problem we have already solved, but I'm going to start with the beginning. So the open loop transfer function of unity feedback system is given by g of s is equal to k by s into s plus 4 into s square plus 4s plus 20. Sketch the root locus of the system. Am I audible? Can anyone message me? Just mention in the chat box. Am I audible? Is my voice clear? Am I audible? Yes, okay, thank you. So let us see. So this is the open loop transfer function g of s. This is an open loop transfer function g of s. If you see in the numerator there is a constant, but in the denominator there is a quadratic term, s plus 4 one term and one s term is there. So by looking at this open loop transfer function, we can say that it has only poles. There are no zeros here. So let us determine the poles. So one pole is, since there is only s here, so one pole is located on the s plane at 0 at the origin. So one pole is at the origin, that is p1 is equal to 0, and another pole is s minus of minus 4. Therefore another pole is located at minus 4 on the real axis. And since there is a quadratic equation here, we can simply determine the roots by using this formula. So you will get minus 2 plus or minus j4. So total we will get 4 poles here. So pole 1 is at the origin on the s plane on the negative real axis, another pole on the lying on the negative real axis on the s plane, and 2 complex conjugate poles we have got. So since there are only poles are represented by x symbol on the s plane, and since there are no zeros, we will assume that since there are 4 poles here, there will be 4 zeros, just it's an assumption, there will be 4 zeros which are lying at infinity. So we can locate the poles, 4 poles that we have got on the S plane. So I have taken scale as 2 centimeter equal to 1 unit. So one pole P1 is at the origin. So second pole P2 is equal to -4. So there is a cross symbol here. So there is a cross symbol here, and complex conjugate poles, that is -2 plus J4. So this is -2, this is plus 4. So this is it, this is one pole. So this is -2 and this is -4. So this is our -2 minus J4. So we have located poles on the S plane now. So let us determine in our step number 2, let us determine the root locus on the real axis. So in order to determine the root locus on the real axis, so what we have to do is, we have to assume a test point on the left side of the extreme right pole on the real axis. There are 2 poles, P2 and P1. There are 2 poles on the real axis. So just first of all, we will go to the extreme right. Extreme right pole on the real axis is P1. So on the left side of this P1, consider a test point. This dot, red color dot, is known as test point. Look towards the right, standing at this test point, look towards the right, count the number of roots on the real axis, sum of poles and zeros. Sum of poles and zeros on the real axis on the right side of this test point is odd number, that is only 1. Therefore, root locus will lie on the left side of this pole until it meets another 0 or pole. So this red line is our root locus, which is traveling from P1 to P2 here. Okay, but P2 is not a 0. So root locus will always start from pole and it will end at 0. So P2 is not a 0, but root locus will lie in between P1 and P2 based on our analysis that we have done just now. Similarly, now let us consider a test point on the left side of P2. Look towards the right. When you look towards the right, standing on the left side of this pole, the sum of poles and zeros, now the sum of roots lying on the real axis are 2, which is an even number. So if it is even number, there will not be any root locus on the left side of this pole P2. Therefore, based on the analysis that we have done just now, there will be only one, there will be a root locus path which is lying between P1 and P2, but this root locus will not travel from P1 to P2 or P2 to P1. Why? Because both are poles. So root locus should always start its journey from the pole and end at 0. Okay, so we have determined, just now we have determined the root locus on the real axis. Now this is our root locus. Blue color line is the root locus that is lying between P1 and P2 on the real axis. Now let us determine the angles of the asymptotes and centroid. So to determine the angles of the asymptotes, the formula for the angle of the asymptotes is 180 degree into 2q plus 1 by n minus 1, where n is number of poles. So our number of poles are 4. M is number of zeros. Number of zeros are 0. There are no zeros. So n is 4. Number of poles 4. Number of zeros is 0. So n minus m. N minus m is 4 minus 0. So what is q? Q varies from 0 to n minus m. So n minus m. 4 minus 0 is 4. Therefore q will vary from 0 to 4. So for different q values, let us determine the angles of the asymptotes. So for each q value, so here when q equal to 0, angle, substitute q equal to 0 here. If you substitute q equal to 0, 2 into 0, 0 plus 1. So 1 divided by n minus m, that is 4. So 180 into 1 by 4, you just solve it. This is what you will get, 45 degrees plus or minus 45 degrees. Similarly, substitute q equal to 1 in the above formula. So 180 into 3 by 4 you will get, you just solve it, you will get 135 degrees. Similarly, substitute q equal to 2 and angle you will get 180 degree into 5 by 4, you just solve it, you will get 225 degrees. 225 degrees 180 is greater than 180 degrees. So always while determining the angles of the asymptotes, if you get an angle greater than 180 degree, then you must subtract that angle with 360. So this is it. So 1 second, I will end the screen. I will just reduce this size. Yeah, now it is far better. So if you see, you are getting 225 degrees, so which is greater than 180. So if you get the angle of the asymptote greater than 180, just subtract with 360 degree. So you will get minus or plus 135 degrees. Now again substitute q equal to 3 in the above formula. So if you substitute q equal to 3, the angle will be plus or minus 180 into 7 by 4, and you will get 315 degrees angle. Just subtract it with 360, you will get 45 degrees, minus or plus 45 degrees. Similarly, substitute q equal to 4 in the above formula, and you will get 180 into 9 by 4, and your angle is 405 degrees, which is greater than 180. So subtract with 360, you will get plus or minus 45 degrees. So overall we have got 135 degrees plus or minus or plus 135 plus or minus or plus 45 degrees. So we have got two angles here. So let us determine the centroid. Centroid is sum of poles minus sum of zeros whole divided by n minus m. So our poles are, one pole is 0, one pole is 0, so one pole is 0, one of our pole is 0, and one of our pole is 0, another pole is minus 4, another pole is minus 2 plus j4, another pole is minus 2 minus j4, minus number of zeros is 0, divided by n is 4, m is 0, so you will get minus 2, minus 2 is our centroid. So now locate the angles of the asymptotes and centroid on the S-plane. So this is it. This is our S-plane. This is our centroid at minus 2. Centroid at minus 2. This purple dot is the centroid, and this is our plus 45 degree angle and plus 135 degree angle. This is our minus 45 degree angle, and this is our minus 135 degree angle. So now at these angles we must draw the asymptotes. You can see you have got total 1, 2, 3 and 4 asymptotes. We have got 4 asymptotes here. So of course we have 4 poles. So all these 4 poles must meet the zeros at infinity. So there must be 4 zeros lying at the infinity, whom these root locus, which is going to start from the pole, should meet the zeros. Okay, so the root locus has to meet the zeros at infinity following the path of any one of the asymptotes. Means each root locus will follow one asymptote to reach the 0, and since there are 4 poles, definitely there will be 4 root locus here. So now let us find whether there is a breakaway and break-in point or not. So to know whether there is a breakaway or break-in point or not, so simply, since an open loop transfer function is given to us, determine the closed loop transfer function. H of s, it is a unity feedback system, therefore H of s is 1. Therefore we are not writing H of s here in this closed loop transfer function equation. Simply we are writing g of s by 1 plus g of s. So substitute g of s in this g of s by 1 plus g of s formula. Substitute g of s, that is k by s into s plus 4 into s square plus 4s plus 20 whole divided by 1 plus k by s into s plus 4 into s square plus 4s plus 20. Just simplify it, you will get k by s into s plus 4, s square plus 4s plus 20 plus k you will get. Now write down the characteristic equation from this closed loop system. Take the denominator and equate it to 0. So if you take the denominator and equate it to 0, this is what you will get. You just solve it, expand this equation, you just expand it, you will get this. After expanding this equation, determine k. So write this whole equation in terms of k. If you write this whole equation in terms of k, you will get k is equal to minus of s to the power of 4 plus 8 s cube plus 36 s square plus 80 s. So if this content is there already, you have written it, okay. If anyone is noting any content in your notes, you can just mention wait in the chat box, so that I will wait for you people to write it down in your notes. So we have got an expression here for k. Now what we have to do is, we have to do some modifications so that we can determine s values, and when you substitute s values in this k equation, k should be real and positive. So this is it. Simply what you have to do is, you just differentiate k with respect to s and equate it to 0. So if you differentiate k with respect to s and equate it to 0, you will get this expression, that is minus of 4s cube plus 24s square plus 72s plus 80 equal to 0. And you further simplify it, you will get s cube plus 6s square plus 18s plus 20 equal to 0. Now you just rearrange these terms. So if you rearrange these terms, you will get s plus 2 into s square plus 4s plus 10 equal to 0. If you are noting it down in your notes, you can just mention wait in the chat box, so that I will wait for a minute and I will proceed. Now this is it. So simply from this term, I can determine the s value, that is s is minus of minus 2. So therefore my root is minus 2. So I can determine one root from this expression. So that is minus 2 is one of my root, s value is minus 2. Other root, this is a quadratic equation, s square plus 4s plus 10. So you just simplify it, and so minus b plus or minus root of b square minus 4ac by 2a. Okay, that's what is the formula. You people already know that, I need not tell you, that's why I have not been telling that. So you just substitute it, in this formula, you will get minus 2 plus or minus j 2.45. Okay, now we have got 3 s values. For these 3 s values, when you substitute in the k equation, k should be real and positive. So now when s equal to minus 2, one of the root is minus 2, substitute s equal to minus 2. When you substitute it, you just substitute it and simplify it. So substitute it in this equation, minus of s to the power of 4 plus 8 s cube plus 36 s square plus 80 s. You just substitute it and solve it. You will get k equal to 64, which is real and positive. So if k is real and positive, that means that there will be a breakaway and break-in point. So another roots are minus 2 plus or minus j 2.45. So I have converted this rectangular form into polar form. I have got 3.16 at an angle of plus or minus 129 degrees. So I have substituted this, instead of taking this rectangular form, I am taking the polar form of s, and I have substituted in this k equation, and I have further simplified it. So this is s power 4. So this s is what? 3.16 at an angle of plus or minus 129 degrees whole to the power of 4. And this is 8 into 3.16 at an angle of plus or minus 120 degree whole to the power of 3, plus this is 36 into s to the power of 2, that is 3.16 at an angle of plus or minus 120 degree whole to the power of 2. 80 into s. So 80 into s is what? 3.16 at an angle of plus or minus 120 degree, 129 degrees. So just solve it. Okay, you have to simply solve it, multiply the terms and all, whatever multiplication terms are there, you just multiply it and solve it, and you will get this expression. You further simplify it. Okay, so you can see here, this is plus or minus, plus or minus, plus or minus, and plus or minus. So in the next slide I have shown you, you can simplify. I just said that you can simplify it. So if it is plus or minus, how can you simplify? So you first of all consider positive terms once and negative terms later. Okay, you can consider negative terms first and positive later, it's your wish. So first of all I have considered all the positive terms. Okay, and I have converted all the polar terms into rectangular form. Okay, I have converted all the polar terms into rectangular form, and I have tried to determine the k value. So what I have got is positive and real value of k I have got. Later I have considered the negative values of the angles. So when I have considered negative values of the angles, I have got a positive and real term of k. So k is real and positive for all these three roots. Okay, so there will be a breakaway or break-in point. So here I can clearly say by looking at the root locus on the real axis that definitely there will be a breakaway point. Why? Because the root locus will start from, I will show you the root locus on the S-plane. So according to this, we already know root locus will start from a pole. Root locus will start from a pole. Okay, so at some point they will meet and they have to break away from each other to meet the zeros. Therefore we can say whether there is a break away or break in point. If there is no confusion at all, we can clearly say that there will be a breakaway point. Okay, there will be a breakaway point at these roots. Okay, so since there are three roots here, s equal to minus 2, s equal to 2 plus minus 2 plus j 2.45, s equal to minus 2 minus j 2.45. These are the three breakaway points. Okay, from where the roots will means root locus will start from the poles. Okay, and at these points the root locus will break and it will try to move forward to meet the 0 at infinity. So I will just erase all links and I will just wait for a few seconds so that if anyone is noting it down, they can note it down. Okay. Now mention those breakaway points on the root locus. So one of the breakaway point is -2, that is exactly lying on the centroid. One of the breakaway point, you can see I have written here breakaway point. Okay, so one of the breakaway point, this is one of the breakaway point exactly lying at the centroid, above the centroid, so overlapping the centroid and say. So this is one of our breakaway point. Another breakaway point is -2. What is it? -2 plus j 2.45. So I will just write it. -2 plus j 2.45. So this is it. Another one is this one, already it is red. So that is -2 minus j 2.45. -2 minus j 2.45. So these are the total 3. This is -2, isn't it? -2. So these are the 3 breakaway points on the S plane. Just note on this. Mention the breakaway points on the S plane. After noting down, if you have completed, you can mention completed so that I can proceed. Okay, I am proceeding. Now step number 5, to find the angle of departure. So in order to find the angle of departure, first of all, let us redraw this whole root locus till now, whatever poles that we have located on the S plane and one root locus path on the real axis, is just redraw that. Okay, on the in your notes, if you redraw it, so you will get somewhat like this. Now consider P3 pole as the reference pole and draw vectors from P1, P2 and P4. So considering P3 as the reference, draw vector from P1, draw vector from P2 and draw vector from P3, which I have already drawn here. So you just do that. Okay, so draw the vectors. Now let us see the angle made by P1 with respect to P3, that is, let us assume it as theta 1. Let us assume angle made by P4 with respect to angle made by P4 with respect to P3 is theta 2. Angle made by P2 with respect to P3 is theta 3. So there are 3 angles here. So and theta 2, we can easily tell that theta 2 value is 90 degree, and theta 3, if I want theta 3, what I have to consider is, I have to consider this right angle triangle. So the opposite to this angle is what? How much? It is 4. The length from here to here, it is 4. What is this length? This triangle, right angle triangle. This is the length of the right angle triangle. So this length is 2, minus 2 to minus 4, minus 2 to minus 4, that is 2. So theta 3 is tan theta equal to 4 by 2, that is theta 3 is equal to tan inverse of 4 by 2. Okay, whereas theta 2 is equal to 90 degree, which I have already mentioned. 90 degrees. So what about theta 1? Theta 1 is equal to, consider I am changing the ink. Consider this triangle, this right angle triangle. Consider this right angle triangle. So what is this angle? What is this angle? Some angle. What is that angle? That angle is equal to what? Tan inverse of that angle is equal to tan inverse of, what is the tan inverse of this length? Opposite is 4. What is the base length? This length, base length is 0 to minus 2, means 2. So 4 by 2. Tan inverse of 4 by 2. So this is the right angle triangle. For this green right angle triangle, the angle made by this angle at this made by this hypotenuse with respect to the base is tan inverse of 4 by 2. So what is the total angle from here to here? What is the total angle? 180. So 180, total angle is 180. Theta 1 is 180 degrees. 180 degree minus 180 degree minus this angle. Okay. So if I write 180 degree minus this angle, that means I will get theta. So what is that 180 degree minus tan inverse of the angle, this angle that we have calculated just now. This is the angle. So tan inverse of 4 by 2. Tan inverse of 4 by 2. Okay. So these are the angles. I will erase all the inks maybe. So these are the angles theta 1, theta 2 and theta 3. So this we have to draw it in our notes, and we should not draw it in our graph. So we should draw it in your notes and determine the angle. So to determine the angles made by the other poles with respect to the reference pole, you must always see if there are any right angle triangles, and you just try to determine the angles within the right angle to determine the angle outside the right angle triangle. If it is within the right angle triangle, the angle such as theta 3 was within the right angle triangle, so it was very easy to determine this angle, theta 3 angle. But in order to determine theta 1, which is outside this right angle triangle, you just consider this right angle triangle. Consider 180 degrees the total base angular length, total 180 degree angle. This is total 180 degree angle. So 180 minus the angle made within this triangle, with in the angle between the hypotenuse and base of this triangle will give us tan inverse of 4 by 2. So this is it. So these where is the angles? Yeah, these are the angles. So theta 1 is 180 minus tan inverse of 4 by 2, theta 2 is 90 degree, theta 3 is tan inverse of 4 by 2. So you just solve this, you will get 117 degrees. Theta 2 anyhow we already know 90, and theta 3 is 3. So these are all the three angles made by vectors which have drawn from P1, P2 and P4 to P3. So just note down these angles. Just note down only these three angles. Okay, now here our aim is to determine the angle of departure. So our step number 5 is actually to determine the angle of departure from the complex poles. So angle of departure we have to determine. So we have determined the angles made by the other poles with respect to P3. Therefore, angle of departure at P3 is 180 minus sum of the angles made by the other poles with respect to P3, that is theta 1 plus theta 2 plus theta 3. So you just add it and subtract it from 180, you will get minus 90 degrees. P3 is the angle of departure at P3 is minus 90 degree, and we already know P4 is the complex conjugate of P3. So since P3 is minus 90 degree, therefore P4 will be plus 90 degree. So the angle of departure of the root locus from pole P3, it is a complex conjugate pole. So that angle is minus 90 for P3, and angle of departure of the root locus from P4 is plus 90 degree. Okay, so now draw the angle of departures. So here I did not draw the angle of departures. You can mention 90 degree means no need to mention specifically, because so I am going to mention the angle of departures here. I am going to just take a pen and so this is my angle, 90 degree angle. This is my angle 90 degree, and this P3 angle, as I have already said, it is plus, I'm sorry, it is minus, and P3 angle is minus 90 and P4 is plus 90. So minus 90, P3 angle is minus 90. So you can write it down here, minus 90. This is minus 90 degree angle, and this is minus 90 degree angle and plus 90. So plus 90 I am going to copy from here. This plus 90. So these are the angles of departures. Now let us go to the next step, that is to find the crossing point on the imaginary axis. To find the crossing point on the imaginary axis. So here let us consider the characteristic equation of the closed loop transfer function, which we have already written, that is s power 4 plus s cube s power 4 plus 8s cube plus 36s square plus 80s plus k equal to 0. Now in order to determine the crossing point on the imaginary axis, you just convert s into j omega. So replace s by j omega. So if you replace s by j omega, you will get j omega to the power of 4 plus 8 into j omega to the power of 3 plus 36 into j omega to the power of 2 plus 80 j omega plus k equal to 0. So you just solve it. You will get s to the power of 4 minus 8j omega cube minus 36 omega square plus j 80 omega plus k equal to 0. So now if you carefully observe, omega to the power of 4 minus 36 omega square and k, they are the real terms here. And if you observe minus j 8 omega cube and minus j 80 omega, they are the imaginary terms here. So first of all, since imaginary terms have only one variable, that is omega, I am going to consider only the imaginary part here and I am going to equate it to 0. So when I am equating the imaginary terms to 0, what I will get here is minus 8 omega cube plus 80 omega equal to 0. So minus 8 omega cube is equal to minus 80 omega. So 8 omega square equal to 80 and omega square equal to 10. And at last if I simplify, I will get omega equal to plus or minus 3.2. So omega equal to plus or minus 3.2, that means what? That means that this is our crossing point on the imaginary axis. So means the root locus will start from the complex poles and they will make an angle of 90 degree, get an angle of 90 degree. The angle of departure is 90 degree, that's what we have got earlier. So since the angle of departure is 90 degrees, therefore so making an angle of 90 degrees at those poles, the root locus will cross the imaginary axis at plus or minus 3.2, means one will pass through point plus 3.2, another will pass through minus 3.2 on the imaginary axis. So am I audible? So now equating the real parts and imaginary parts. Okay, already imaginary parts we have equated, remaining is only real parts. So now we are equating only the real parts. So if we equate the real parts, you will get omega to the power of 4 minus Am I audible? Am I audible? Am I audible? Can anyone mention? Am I disconnected or? Okay. If I am disconnected, someone WhatsApp me. My voice is not clear. Okay. 1 second. I still have connectivity issue. I didn't change my connection. Internet connection is the previous connection which I used to use. Same I am using. So maybe there may be due to connectivity issue. Maybe my voice is being is not clear. So okay, let me continue. So now here we are going to equate the real parts to 0. So omega to the power of 4 minus 36 omega square plus k is the real parts in the above equation. You just equate it to 0. We have already determined omega value. So let us determine k value. So k you will get minus omega to the power of 4 plus 36 omega square. Substitute omega equal to 3.2. So if you substitute omega equal to 3.2, you will get 9k equal to some 4 into 11 plus k. So k you will get 260. So that means that for this value of k, the system will be stable. Okay, so you have to know for what value of k. Okay, so k is nothing but proportionality constant. Okay, so for what value of k your system is stable. That's it. So for 260, your system will be a stable system. So it is the limiting value of k. This is the limiting 260 is the limiting value of k for which for the stability of the system. Okay, now let us draw the omega value that is crossing point values, that is whatever you have got 3.2 and 3.2. Okay, 3.2 was the crossing point. So what I will do is I will take previous graph. I will take the previous graph. I will mention the crossing points. 3.2 here. I will take some other color. Yeah. So this is my 3.2 dot approximately. Okay, approximately this is my 3.2 crossing point on the imaginary axis. These two, these purple dots, this purple dot and this purple dot, they are the crossing points on the imaginary axis. So I have mentioned the crossing points on the imaginary axis. So this is it. So these are the crossing points on the imaginary axis. So mention the crossing points on the imaginary axis. Now we have breakaway points, and we know the angle of departure, we know the crossing point on the imaginary axis. Now we can draw the root locus. So you can draw the root locus now. So you can see here, simply what you have to do is, you just check, here, there is a pole here P2, there is a pole here P1. So from pole P1, root locus will start. From pole P2, root locus will start. From pole P3 also root locus will start. What is the angle here? Angle departure 90 means straight away. This is my root from P3. Angle of departure from P4 is also 90 degrees. So this is my root locus from P4. So these are the root locus. From P3, this is my root locus. From P2, this is my root locus. From P4, this is my root locus. Okay, and P2, this is my root locus. And it will reach up to the breakaway point. So from P4, breakaway point is what on real axis? -2. Okay, breakaway point is -2. So from P2 to breakaway point, from P1 to breakaway point. Okay, so the root locus will start from P1. It will reach until it meets breakaway point. What is our breakaway point on real axis? -2. Therefore, root locus start from P1. It will reach the breakaway point, this -2 on real axis. Root locus will start from P2. It will reach the breakaway point on the real axis, that is -2. Now, from P3, root locus start at an angle of 90 degree and it will reach the breakaway point. That is what was it? -2. What is it? I forgot the breakaway point on the. So breakaway points are -2 plus J 2.45 minus J 2.45. Okay. Yeah. So this is -2 plus J 2.45 breakaway point. This is -2 minus J 2.45 breakaway points. So root locus start from P4 till the breakaway point, P3 till the breakaway point, from P2 to the breakaway point, and P1 till the breakaway point. Okay. So after reaching the breakaway point. Okay. So after reaching the breakaway point, what should happen is the root locus path should. The root locus, that is what is happening? Yeah. So the root locus, what to say here? The root locus should break. Okay. So root locus actually there was a root locus between P1 and P2 that should break. So one path from P1, it may move upward. Okay, it may move upward towards the another breakaway point. And from P2 it may move downward towards the breakaway point. From this breakaway point, at this breakaway point -2, what is happening? One path from P1 it may move upward, another path which is coming from P2 it may move downward, or from P2 it may move upward, from P1 it may move downward. It doesn't matter, it may move in any direction. So okay, I will take different colors and later I will draw. Now our root locus, what is happening? Let us assume from P2 root locus has started. It has reached the breakaway point. From this breakaway point, which is the P2 root locus is moving downward. From P1 root locus has started. It has reached the breakaway point. From here root locus has moved upward towards the another breakaway point. So at this point, that is -2, minus j 2.45 I think. Okay, at this breakaway point what is happening? A root locus from P2 is coming towards this breakaway point. A root locus from P4 is coming towards this breakaway point. So they are meeting here once again. Two root locus are meeting here once again. So one root locus will take the path towards this asymptote, and the root locus will take the path towards this asymptote. Okay, we have to draw with free hand. Okay, so maybe root locus which is traveling from P2, it will reach the breakaway point. From there it will travel and reach the breakaway point, and it may travel towards this asymptote. From P4, root locus will reach this breakaway point. From here it will take the turn and it will move towards the, follow the path of this asymptote. Okay, next from P1, root locus started, it has moved towards this breakaway point. And from P3, root locus has started, it has moved towards this breakaway front. At this point, what is happening? From P1, root locus has started and reached this breakaway point. Now, P3, it has started and reached this breakaway point. From here, at this point, again, these two root locus which are meeting here, they will break away. So, one will move and follow this root, this asymptote, passing through this imaginary, what is it, crossing point of the imaginary axis. I forgot this crossing point. It should, I might have drawn somewhat like this, passing through the crossing point of this imaginary axis. On this side also, there is no crossing point. But what you have to do is exactly at this location, at the same distance. What is the distance from origin to this breakaway point? How much? 4. It is minus 2, isn't it? From here to here, consider minus 2 means minus 4. From minus 4, draw same dot like this. Of course, it is not the crossing point, but draw the dot at this point. Just put a dot here. And similarly, here also, this length is 4 minus 2. Consider minus 2. Wherever you have put the dot, at the same location on the other end, put the dot and draw the root locus with free hand. Once again, I will explain. So, here first of all, how many poles are there? P1, P2, P3 and P4. Total 4 poles are there. Okay, total 4 poles are there. So, root locus from P2 it will start and it will move like this. From P1 it will start and move like, I will remove this brackets which I have put just now, erase all links. Now, root locus will start from P1, it will move in this direction. From P2 it will start, it will move until in this direction until they meet a breakaway point. Where is the breakaway point? Here. There is a breakaway point here. Okay. So, they will meet the breakaway point. So, after meeting breakaway point, what will happen? P2 may move from this breakaway point to upwards, P1 may move downwards. Okay. They can take any direction, their wish, we can't say. So, let us assume P2 is moving downwards. So, from P2, the root locus will move downwards, let us assume. If P2 root locus is moving downwards from this breakaway point, P1 will move upward. So, root locus from P1 from this breakaway point will move upward. Okay. Now, after reaching this breakaway point, what will happen is, maybe the P2 root locus may, from this breakaway point, since there is no breakaway point further, therefore, it has to follow the path of asymptote. So, there is an asymptote this side. So, P2 may follow the path of asymptote or the other asymptote. Okay, this one or this one. It can follow any of these two asymptotes, but because it is moving downwards according to our assumption, so it may follow any path. So, I am assuming that it follows the path of this asymptote. Okay. So, before that, if you see here, there is a crossing point here. Similarly, exactly symmetrical to this point, put a dot here. Okay, put a dot here. So, you want to know symmetrically at this point, you are putting a dot. You just check the length from here to here. How much is the length? What is the length? Minus 2. This is minus 1, minus 2. So, this is minus 2. So, from here to here, as consider minus 2. That is minus 4. At minus 4, at 2. I think this is the point. Just put a dot to get a symmetrical locus. So, similarly, here there is a dot here. So, since there is an asymptote here, another asymptote. So, this is the crossing point, exactly symmetrical to that. At this location, I am going to put a dot. Okay. I hope you know what is meant by symmetry. So, now we have put some dots here, so that you will get the symmetrical waveform. So, now from this P1, as I said, P1 will reach this breakaway point. From here, it will move upward. From here it will move upward, it will reach this breakaway point. Maybe it will follow this asymptote passing through the crossway point like this. So this is the path of P1. Now from P3 at angle of 90 degrees will start, it will reach this breakaway point, and from here it will asymptote passing through this point. For symmetry we are putting the point, otherwise you can draw with freehand, it doesn't matter. So from P2 root locus will start and it will reach breakaway point. It will move like this, and from here it may follow this asymptote passing through this crossaway point. So this is the mark. Now from P4 at making an angle of 90 degree, root locus will start from P4, move like this, and it may follow the path of this asymptote passing to this point. These points, you know, this point and this point we have considered in order to make the plot uniform and symmetrical. Okay. So this is our plot. To make it more easy, I am going to take in order to differentiate between root locus, I am going to consider different colors. Okay. So let us assume from P1 root locus starts, and it made this breakaway point, and it will go upward, and from here passing through this crossing point it will flow like this. So this is the root locus 1. Okay. Another root locus, I will consider another this color. From P2 root locus will start, it will move downward, it will meet this breakaway point, it may follow this path passing to the crossaway point, this is it. So as I said, symmetrical to this this crossing point, I am drawing another point here symmetrically. So you know what is meant by symmetry, and similar to this crossing point, I am going to draw another crossing point here symmetrically. Now I am going to take another color. Yeah. So from P3 root locus will start, it will reach this breakaway point, and from here it will start to follow the path of this asymptote. Okay. So another P4 root locus is there. I am going to take this color. The root locus start from P4, it will reach this breakaway point, and it may follow the path of this asymptote. So you just see the colors. There are 4 root locus here. So one starting from P1 moving like this. Okay. So I will take maybe I will take red color. So one root locus path is somewhat like this. This is one root locus. Root locus of P2 is somewhat like this. Root locus can take, so after reaching the breaking point, root locus can travel in any way. So this P2, it can travel from here to this breakaway point, from here to this breakaway point. From here it might have traveled like this. Okay, it might have traveled like this. Instead of that, I have drawn like this. Wish you can draw anyway, because these are all just the assumptions. Okay, and from P3 root locus has started like this and it has traveled like this, and from P4 root locus has started like this and it has traveled like this. Okay, these are the 4. Just the red color arrow marks. So by looking at the red color arrow marks, you can easily identify 4 root locus paths. So root locus can move either upward or downward. Okay, it is not, there is no particular restriction for the path of root locus to that. One root locus should always move downward, another root locus should always move upward. One root locus should always move right side, another locus should always move left side. There are no restrictions, your wish. Okay, you can draw anyway. So that's why, in order to avoid all the confusions. Okay, simply you just draw the root locus like this. This is the root locus for the given numerical problem. Just note it down. Voice is not clear, maybe because of connectivity issue. The voice is not clear. So we don't have any other option. Anyhow, I have to take the class, I don't have any other option. I'll change my internet connection later. Actually, just if my voice is not audible, look at this screen and try to understand. The best that I can do, I am doing. Video and voice I'm switching. Okay, because of this buffering, maybe. Maybe because of connectivity issue. So I will solve one more problem and I will give you a break. We will solve one more problem and later I will give you a break. Okay, so numerical problem. So if my voice and video are mismatching, you just go through the screen because I don't have good connection here to take the class, but because I don't have any other option, that's why I am taking the class today. Okay, then the open loop transfer function of a unity feedback system is given by g of s. So that is g of s is equal to k into s plus 1.5 by s into s plus 1 and s plus 2, s plus 5. So here, by looking at this g of s open loop transfer function, we can say that there are zeros and poles. Of course, there is only 1 0 and 3 poles. Directly you can write it down, and you have to sketch the root locus, and it is a unity feedback system. That means unity feedback means h of s is equal to 1. H of s is equal to 1. That is unity feedback system. Okay. So now step 1. Step 1, to locate the poles and zeros. Look at the poles and zeros. So the poles are what? S equal to 0, S equal to minus 1, S equal to minus 5. Directly you can write it down, isn't it? S equal to 0, S equal to minus 1, S equal to minus 5. Or you can write as P1 equal to 0, P2 equal to minus 1, P3 equal to minus 5. And what about Z? Z1 equal to minus 1.5. Z1 is equal to minus 1.5. So voice may be unclear because of connectivity issue, not because of mic issue. Okay. Because of connectivity issue, my voice may not be clear. Okay then. Now, so 1 0, that is minus 1.5 is known. There are 3 poles. Since there are 3 poles, there will be 3 zeros. We have only 1 0, that is minus 1.5. So other 2 zeros, we will assume that they are lying at infinity. Okay, so Z2 and Z3 are at infinity, whereas Z1 is minus 1.5, and we have 3 poles, P1 equal to 0, P2 equal to minus 1, P3 equal to minus 5. So here, let us locate these poles and zeros on the S plane. I have considered 2 centimeter equal to 1 unit. So P1 is 0, P2 is minus 1, P3 is minus 5, Z1 is minus 1.5. Z1 is minus 1.5. So Z1 is minus 1.5. So these are the roots on the S plane. If you observe, all the roots are lying on the real axis. There are no complex poles or zeros. Even zeros can complex zeros. Okay. So here we have got all real poles and real zeros. 1 real zero and 3 real poles. So if you are getting all the poles and zeros as real one, then there is no need to determine the angle of departure. So that is one of the burden is reduced now because of this. Okay. So if our burden is reduced, that's a good what to say. That's one of the good opportunity because the work that you have to do for solving this numerical problem is reduced. So burden on you is reduced because of that. Now, this is our first step, locating the poles on the real axis. Because we have got all the poles on the real axis, 0 is also on the real axis. Just locate them on the real axis. Considering 2 centimeter is equal to 1 unit. I'll give you a second, 2-3 minutes at least to draw it. Is my voice audible now? No? Okay, then I'll proceed. Our step number 2 is to find the root locus on the real axis. For that, let us go to the S plane where we have located the poles and zeros. Now extreme right root is P1. So consider a test point on the left side. Consider a test point on the left side. Look towards the right side. Sum of poles and zeros on the right side is odd. Therefore, there will be a root locus from P1 to P2. There will be root locus from P1 to P2. Now, consider a test point on the left side of P2. Look towards the right. Sum of poles and zeros is even. 2 poles are there. 2 poles are there. Therefore, there will not be any root locus from P2 to Z1. Okay. So, now here there is a root locus from P2 to P1. There is root locus from P2 to P1. But between P2 and Z1, there will not be any root locus. Why? Because if I consider a test point on the left side of P2, if I consider a test point on left side of P2 and if I look towards the right, sum of poles and zeros on right side, that is number of roots is even number. Therefore, there will not be any root locus on the left side of P2. So, there will not be any root locus between P2 and Z1. Okay. Now, consider a test point on the left side of Z1. Consider a test point on the left side of Z1. Okay. And look towards right side. Look towards right side. Yeah, look towards right side. When I look towards right side, sum of poles and zeros is odd. Okay, sum of poles and zeros means sum of roots is odd number. Therefore, there will be a root locus on the left side of Z1 until it meets another pole or 0. Until it meets another pole or 0. Okay, so there is a root locus from Z1 to P3. Okay, so these are our root locus. We have 2 root locuses here. So, but always remember root locus, even though there is root locus from Z1 to P3, root locus will not start from 0, it will not end at P3. It will always start from pole and it will end at 0. Now once again consider a test point on the left side of P3. Okay, consider a test point on left side of P3. Look toward the right. Consider a test point on left side of P3. Look towards the right. When you look towards the right, the sum of roots is 4. 3 poles and 1 0 is the total 4. So, is an even number. Therefore, there will not be any root locus on the left side of P3. Okay. There will not be any root locus on left side of P3. There will not be any root locus in between P2 and Z1. But there will be a root locus in between P1 and P2. There will be a root locus in between P3 and Z1. Okay. So, of course, by looking at this diagram, what you can say that this is a pole, this is a 0. Definitely, there is a root locus between those two. So, definitely the root locus should come from P3 to Z1. That's it. It's connected. Pole and 0 are connected by this root locus. And there should be the root locus should travel from this pole to this 0. So, you can put an arrow mark here itself. Okay, directly without thinking anything else, you can directly put an arrow mark like this. So, this is we have found the root locus on the real axis. These are the root locus. Okay. Is still my voice mismatching with the screen? Is my voice mismatching or is it not clear? Okay. So, step number 3, to find the angles of asymptotes and centroid. So, to find the angles of asymptotes, as we already know, this is the formula. Angle of asymptotes is 180 degree into 2q plus 1 by n minus m. N value, number of poles, I think it's 3. Number of zeros, it is 1. So, 3 minus 1, you will get 2. So, q will vary from 0, 1, 2. Q will vary from 0, 1, 2. This is it. Q will vary from 0, 1, 2. So let us determine for different Q values the angles of asymptotes. Okay. So for different Q values 0, 1, 2, Q equal to 0, angle you will get 180 by 2, so that is plus or minus 90 degree. Q equal to 1, angle is 180 into 3 by 2, that is 270 you will get, which is greater than 180. So 270 minus 360 you will get minus or plus 90. Substitute Q equal to 2, angle you will get 180 into 5 by 2, that is 450 degrees you are getting. Subtract it with 360, you will get plus or minus 90 degrees. So we have got all 90 degree angles. So angles of the asymptotes are 90 degrees. Angles of the asymptotes are 90 degrees. Now let us consider the centroid. Let us determine that sum of poles minus sum of zeros by n minus m. Okay, sum of poles minus sum of zeros. There is something here. Okay, whatever. So here centroid, you can see you will get centroid as minus sum of poles minus sum of zeros you will get. So just some issue is there here, I want to undo. Yeah, this is it. So sum of poles minus sum of zeros by n minus m. So sum of poles are 0 minus 1 minus 5, zeros are minus 1.5, so divided by n is 3, m is 1. So you just solve it, you will get minus 2.25. Minus 2.25 you will get. So just locate the centroid on the real axis and mention the angles of the asymptotes on the real axis. You will get this. This is what you will get. So you can see this is 2.25 centroid, that is the purple dot. So angle made by the asymptotes with respect to real axis is 90 degree. These are the asymptotes. Now let us go to the step number 4 to find the breakaway and break-in point. To find the breakaway and break-in point, we have to determine the closed loop transfer function, and we already know in the question they have mentioned that it is a unity feedback system, therefore h of s is equal to 1. Therefore in the closed loop transfer function equation I didn't write h of s directly, I have considered only g of s. So c of s by r of s equal to g of s by 1 plus g of s. You just substitute g of s here, k into s plus 1.5 divided by s into s plus 1 into s plus 5. Okay, so just solve it. You will get k into s plus 1.5 by s into s plus 1 into s plus 5 plus k into s plus 1.5. So consider the characteristic equation. Take the denominator equal to 0. Take denominator and equal it to 0. You get this and solve it to determine the k. Of course, you will not get the k value, but you will get an expression for k. So this is the expression for k. You just simplify, just rearrange the terms. That's it. Nothing else. You just rearrange the terms. Rearrange the terms. You will get equal to minus of s cube plus 6s square plus 5s by s plus 1.5. Okay, this is it now. This is it. This is the expression for k. Now, let us differentiate k with respect to s and equate it to 0. If you differentiate k with respect to s and equate it to 0, and if you simplify it, you will get this expression, that is s plus 0.6 into s square plus 4.65s plus 6.2 equal to 0. This is what you will get. Now determine s value, that is s equal to minus 0.06, what that is one root, and the root is complex roots you will get. There you just this is a quadratic equation, isn't it? So this is a quadratic equation. So you just simplify it, you will get s equal to minus 2.3 plus or minus j 0.86. Okay. So now substitute s value in the above equation of k and solve it. You will get k as real and positive. So if k is real and positive, there should be a breakaway point here. Breakaway point will be there because you can see two root. You can see two poles are meeting together. Means root locus is joining two poles. So definitely root locus should start from these two poles and it should break away to meet the zeros. Okay. So there will be a breakaway point. And so now substitute s equal to minus 2.3 plus j 0.86 and again substitute minus 2.3 minus j 0.86 and solve it. So here I didn't solve it. I have given the conclusion. You just substitute that in the above equation and solve it. You will get k. You will see that k is not positive and real. So these points cannot be actual breakaway points. So our actual breakaway point is what now? Minus 0.6. Okay, minus 0.6 is our breakaway point, whereas this is these two are not our breakaway points. Only one breakaway point is there. I will erase all links. So only one breakaway point. This is a breakaway point, but this is not our breakaway point. Okay, so let us consider this breakaway point. For that breakaway point, k is real and positive. So just represent it on the real axis. Minus 0.6. Okay, now we know the breakaway point. Let us move forward to solve the numerical problem further. Now step number 5. As I said, there are complex poles. So to find the angle of departure is step number 5. Since there are no complex poles or zeros, so there is no need to find the angle of departure or angle of arrival. So angle of arrival is determined if there are zeros. Of course, there are no complex zeros. There are complex zeros. Okay, so there are no complex zeros. Angle of departure is from the poles. Angle of arrival is for the zeros, complex zeros. So in our numerical program, there are no complex poles or no complex zeros. So we need not worry about. It. Okay, because there are no complex zeros or complex poles, so there will not be angle of departure. Why? Because there are no complex poles. There will not be any angle of arrival. Why? Because there are no complex zeros. Okay, so because root locus will reach 0, therefore angle of arrival. Root locus will start and move away from pole, therefore angle of departure. Okay, step number 5 is no need in this numerical problem because there will not be any angles. So now let us go to step number 6. Find the crossing point on the imaginary axis. So let us check that. So let us consider the characteristic equation. Okay, so that is s into s plus 1 into s plus 5 plus k into s plus 1.5 equal to 0. That is our characteristic equation, and just simplify it. You will get s cube plus 6s square plus 5s plus ks plus 1.5k equal to 0. So now replace s by j omega in the above equation. You will get instead of s, wherever s is there, just write j omega. So j omega cube plus 6 j omega square plus 5 j omega plus k into j omega plus 1.5 k equal to 0. There is no omega here, so leave it. So you just solve it, you will get this. Now compare. Now consider only separately imaginary values, that is minus j omega cube plus j 5 omega, minus j omega, so minus j omega cube plus j 5 omega and j k omega. These are the imaginary terms. Real terms are minus 6 omega square and 1.5 k are my real terms. So now I am equating the imaginary terms. So if I consider only the imaginary terms and equate it to 0, what do I get is j minus omega cube plus 5 omega plus k omega equal to 0. So omega square equal to 5 plus k I will get. Now equating real parts to 0, 6 omega square plus 1.5 k equal to 0. Now we already know omega square is what? 5 plus k. Substitute that in this second equation, you will get k value. K value is minus 6.67. For this value of k, system will reach the stability, we can say, or system will be stable for this value of k. Okay. One minute. Now if you observe, I didn't mention that. If you observe, what is our k value? It is negative. So if k is negative, there will not be any crossing point on the imaginary axis. Okay. There will not be any crossing point. So root locus will not have any crossing point on the imaginary axis. So now root locus. So whatever breaking point that we have, the root locus will start from P2. It will travel towards the breakaway point P1. It will start and it will travel towards the breakaway point. From there, it will try to reach the asymptote and start to travel towards the infinity to meet the 0. Okay. So traveling parallel to the asymptote. So you can see here simply. So there should be an arrow mark here. Okay. So from P3, root locus will start and move towards Z1. That's it. That is one root locus. Another root locus is from P1, it will start and it will start to move towards the 0 following this asymptote. From P2, root locus start and move towards 0 following the lower asymptote. Maybe the root locus that is traveling from started from P1 may follow the lower asymptote, and the root locus that has started from P2 may travel upward. Okay, so in either direction the root locus can travel. So direction is not important. So this is the root locus for the given numerical problem.